Biomass will shed some light on the role of forests in the global carbon cycle. Forests play a very important role in climate change. They do this in two ways. So if you take a tree, half of the tree is carbon. If you cut down a tree or if it burns, then all this carbon is released to the atmosphere and it contributes to global warming. At the same time, trees can soak up enormous amounts of carbon from the atmosphere. In fact, they are so effective that they are one of the main mitigation options in fighting climate change. One of the big challenges we have today is that we don't know a lot about this biomass ecosystem or these forest ecosystems. And biomass will help us to take observations and to measure especially the carbon stocks and how they changes over time. Biomass will contribute where we know least and we have the biggest knowledge gaps. So the whole mission is designed to measure, especially in tropical forests, which are the most diverse forests and which hold most of the carbon in the world. Biomass is designed to be very sensitive and to measure where no other sensor can measure, and to provide information on the stocks, but most importantly also on the change of these stocks with time. Biomass is a science mission, so our main data users is the scientific community. And here it's especially the forest ecology community and the carbon cycle community that are interested in these data sets. But beside this, biomass also contributes to societal needs. Governments have agreed in the face of climate change to take action against deforestation and to protect our forest by giving financial incentives to especially developing countries. To see if these actions are effective and how they are effective, biomass will provide us essential data. And we expect the mission to go far beyond its primary mission objective. Biomass is an Earth explorer in the best sense of its name. We are looking at the Earth in a way no one else has looked at it before. And we expect that despite the name suggests we are only looking at forests and biomass, we will also deliver precious data to observe the cryosphere, the desert, or even the ionosphere. Biomass is an Earth explorer, and like every Earth explorer, it's a bit like a journey into the dark. So we will only know when the mission is up there in space what we will get. Of course, we prepare for the mission, so we do our best to our knowledge. We build, for example, digital twins of the instrument to really test and test all aspects of the mission. We put instruments on the ground or in airplanes to see if the measurements we take comply with the needs and requirements of our scientific community. But at the end, we will only see when the mission is in space what we will get and which challenges we will face. A big reward of this mission will of course be when the mission is in space and we will receive the first signal and we will see that the system is healthy and is delivering data to the ground. Building a satellite like Biomass is like running a marathon. So we started this process already 20 years ago, and of course it's very exciting for the whole team to see this satellite shaping up and eventually being launched into orbit. But maybe the biggest reward will be once we get the first images and once we start exploring and discovering together with our scientists what we can learn from this mission.